Hey everyone, I hope you're doing well today. In this video, let's practice converting polar equations into rectangular form. Before we try some examples together, these are some helpful equations and identities that will help us convert polar equations to rectangular form. Throughout this video, I encourage you to pause often and try some of the problems on your own if you're feeling comfortable, but if not, feel free to just do them with me. I encourage you to grab some paper, something to write with, and let's do some math together. For example 1, let's convert the polar equation r is equal to 4 times sine of theta. To begin, let's multiply both sides of this equation by r. The reason I'm going to do so is so that we can get r squared on the left side. So r times r on the left side is just going to be r squared, and on the right side we're going to have 4 multiplied by r times sine of theta. Now, we know that r squared is equivalent to this x squared plus y squared, so making that substitution, we can just write on the left side x squared plus the y squared. Go ahead and put y squared, and that's going to be equal to 4 times, well, take a look at this r times sine of theta. R times sine of theta we know is right over here, and that's equivalent to just y. So making that substitution, we can write 4y. Technically, this equation is in rectangular form since we don't have any r's or thetas anymore, we just have x's and y's. But rearranging this, we could write our solution this way as well and write x squared plus this y squared, and subtract the 4y from both sides, we can say minus 4 times y, and that's equal to 0. This would be the rectangular form of this polar equation. For example 2, let's try the polar equation r is equal to negative 2 times cosine of theta. Just like the last example, let's start by multiplying both sides by r so we get this r squared. On the left side, we can then write we have r squared, and this is going to be equal to negative 2 times r times cosine of theta. Remember, r squared is right over here, and that's equal to this x squared plus y squared, and r cosine of theta is located over here, and that's just equal to x. Making these substitutions in, we can then write on the left side that we have x squared plus y squared, and then on the right side, we're going to have negative 2 times x. Adding x to both sides, we can write our final rectangular equation as x squared plus this y squared that was already on the left, but moving that negative 2x over to the left side, we're going to add 2x and set that equal to 0. There's our rectangular form. For example 3, let's try the polar equation theta is equal to 2 pi over 3. Now, when you're given this equation that just has theta on one side, I recommend taking tangent of both sides. So if we do that, on the left side we'll have tangent of theta, and on the right side that's going to be equal to tangent of this 2 pi over 3. So remember that tangent of theta is located right over here, and that's equal to the ratio of y over x. We can see that here. And so we can substitute that in and say this is going to be y over x. That's on the left side. Now for the right side, we have to figure out what this tangent of 2 pi over 3 is. Now try to recall that 2 pi over 3 is basically 120 degrees, and that goes over into quadrant 2. So this would be a 60-degree reference angle. And what are those measurements? Well, we have negative 1 and a positive 2 for the radius there, and then a root 3. And that's going to be positive because it's a y value. So if we go with tangent, which is going to be y over x, that's going to be a positive root 3 over a negative 1, or the opposite over adjacent. So we now know that this is going to just equal negative square root of 3. That's what tangent of 2 pi over 3 is. Now, if we want to just rearrange things a little bit, we can multiply both sides by x here. And in doing so, these x's on the left side are going to cross cancel, and we'll just have y is equal to the negative square root of 3 times x. And to get everything on the same side and make it equal to 0, we can add negative root 3x to both sides, and then we'll get positive root 3x on the left side, plus the y, and that's going to equal 0. This would be a rectangular form of the equation. For example 4, let's try the equation theta is equal to 11 pi over 6. Just like the last example, let's go ahead and take tangent of both sides since we just have a theta on the left side again. So we'll write tangent of theta is equal to tangent of this 11 pi over 6. 11 pi over 6, just like that. And on the left side, just like earlier, we can check to see if we have a substitution. Tangent of theta, that's just equal to this y over x. So on the left side, we'll write y over x. And then on the right side, we really have to figure out what this tangent of 11 pi over 6 is. Now, 11 pi over 6 is really close to 2 whole pi's, or 360. It's just 1/6 short. I know 1/6 of a pi is 30 degrees, so that's going to be right over here for our reference angle. So here is our 30-degree reference angle. This is a negative, let's see, this is a positive x value, so this is going to be, we have 1 to 2 to root 3. That's the ratio for a 30, 60, 90 triangle. This is a positive x value going to the right, but it's a negative y value going down. So let's see, tangent of this reference angle, tangent of 30, would be opposite over adjacent, or y over x. And so that would be -1 over root 3, or positive root 3. Going ahead and rationalizing the denominator on the right side by multiplying by the root 3 over root 3, we can then see that we'll have an equation as y over x on the left side. That stays the same. That's going to be equal to this negative root 3 over 3 on the right side. Then we can multiply both sides by x, and if we do so, the x's on the left side will cancel out. We'll have y is equal to this negative root 3 over 3x. Now, just to rearrange everything so it's all on the left side, if we add the negative root 3 over 3x to both sides, we'll then have positive root 3 over 3x plus the y, and that's going to equal 0. There's our rectangular form. For example 5, let's try the polar equation r is equal to 4. When you see equations that look like this, I strongly recommend just squaring both sides of the equation. If we square r on the left side, we'll just have this r squared, and on the right side we will have 4 squared is equal to 16. And if you take a look at this r squared, well, we know what r squared is equal to. We've done this a few times now. That's equal to this x squared plus y squared. So we can write x squared plus the y squared, and that's going to be equal to 16. And we can leave this equation in this form. This is just an equation of a circle with the radius of 4, and its center is at the origin. In example 6, let's try the equation r is equal to 4 times cosecant of theta. So remember that cosecant of theta is just 1 over sine of theta, so let's rewrite this equation in terms of sine of theta instead. So we'll say r is equal to 4 over, we're going to write sine of theta. Now let's go ahead and just multiply both sides by sine of theta. When we do so, on the left side, we're going to have r times this sine of theta, just like that. And on the right side, those sine of thetas will cancel out with each other, and this is just going to equal 4 on the right side. Hopefully you can start recognizing this r times sine of theta, that's right over here, and that's just equal to y. So making a substitution, we can swap out y here and say that y is equal to 4. There's our answer. For example 7, let's try the equation r is equal to -3 times secant of theta. Secant of theta is the reciprocal of cosine of theta, so we can rewrite this as r is equal to -3 over cosine of theta. Multiplying both sides by this cosine of theta. On the left side, we're just going to have r times this cosine of theta, and on the left side, we're going to see that those cosine of thetas are going to cross cancel, and we'll just be left with -3. Now, this r times cosine of theta, we want to make sure that looks familiar to us. That's right over here, and that's just the same thing as x. So making a substitution, we can say this is going to be x is equal to -3. There's our rectangular form. For number 8, let's try the equation r squared is equal to cosine of theta. So on the left side, this r squared, let's try to remember that is just equal to this x squared plus y squared. So I'm going to start with that substitution first. Let's swap out the r squared and instead write this x squared plus the y squared. And on the right side, let's just leave that alone for now and say that's cosine of theta still. This cosine of theta on the right side is a little problematic. So looking at this cosine of theta, we know that's x over r, but then we're going to still have an r involved. Or we could also take a look over at this equivalency, and we know that r times cosine of theta is equal to x. Either way, though, we're going to have an r involved here. So either one is fine for you to use. To use for this one, I'm actually going to try this one. We're going to multiply both sides of the equation by r so that we have r cosine of theta. So let's go ahead. I'm going to multiply both sides of the equation by the r value. Okay. So if we do that, then on the left side of the equation, we'll have r times the quantity of this x squared plus the y squared. All right, that's going to stay the same. Nothing's really going on too much over there. And on the right side, we're going to have this r times the cosine of theta. And let's see why we chose to do that, or why I chose to do that here. So on the right side, we really have this r times cosine of theta. And again, that's just equal to this x value. So the left side is going to stay the same. We'll have r times the quantity of x squared plus the y squared. But on the right side, we can swap out the r times cosine of theta and just write x instead. So the frustrating thing about this equation that we still have to deal with is this darn r over here on the left side. So we don't really know what r is equal to, but we do know what r squared is equal to. So at this point, let's go ahead and just square both sides of the equation. Squaring both sides, we're going to have r squared times the quantity of x squared plus y squared. And this whole thing is also going to be squared, and that's going to equal on the right side x squared. Now we have this r squared, which we know how to deal with. We can make a substitution. So r squared is the same thing as x squared plus y squared. So we're just going to substitute that in. So that's what r squared is, and that's going to be multiplied by what we still had on the left side, which is x squared plus the y squared. That just stays the same. That whole thing is squared. And this is equal to x squared on the right side. This binomial to the left is the same as the binomial to the right, so given that they have their exponents, we can just add them. Then on the left side, we can really say we're going to have, let's move this up over here so we have a little bit more space. We'll have the quantity of x squared plus y squared. That's all staying the same, but this is all going to be raised to the third power now, and that's going to be equal to x squared on the right side. So technically this is in rectangular form because we don't have any r's or thetas, but let's go ahead and see if we can set this equal to 0. So to do that, I'm going to raise both sides to the 1/3 power, and in doing so, that's going to be canceling out with the third power. So on the left side, we're just going to have this x squared plus the y squared. That's going to be on the left side, and on the right side, x to the second power raised to the 1/3 power is just going to be x to the 2/3 power. Subtracting the x to the 2/3 power from both sides, we can then write x squared plus the y squared. That stays the same, and we're going to take away this x to the 2/3 power and set that equal to 0. And that'll be our answer. For number 9, let's try the equation r squared is equal to sine of 2 theta. So right away on the left side, this r squared, we know what that's equal to. Let's make that substitution. So we'll write x to the second power plus y to the second power. Hopefully you're getting used to that by now. And on the right side, if you take a look at this, this is just our double angle formula. So if we take a look at what sine of 2 theta is equal to, again, that's just equal to this 2 times sine of theta times cosine of theta. That's just one of your trig identities. So we can go ahead and substitute that in and make that swap. We can say this is going to be 2 times sine of theta multiplied by cosine of theta. We should be pretty happy with the left side right now because we just have x's and y's, but the right side, we have to somehow get rid of these sines and cosines, get rid of these trig functions. So looking ahead at this sine of theta, what is sine of theta equal to? Well, that's just equal to this y over r. And looking at cosine of theta, that's over here. That's the adjacent over hypotenuse, or x over r. So let's go ahead and make some swaps and some substitutions. So this is going to be 2 times what's sine of theta. It's going to be y over r. So go ahead and write y over r just like that. And then going ahead and writing what was cosine of theta equal to, we said that was x over r. So go ahead and write x over r. Let's just keep the left side the same for now. We're pretty happy with how that looks. And on the right side, we can simplify some things here. So in the numerator, we can rearrange it a bit and just say this is 2xy, or 2 times x times y. And in the denominator, we should have r squared. We should be pretty happy with seeing this r squared. On the left side, this is just going to stay the same. We'll have this x squared plus y squared. And on the right side for the numerator, we'll still have this 2 times x times y. But in the denominator, we're going to swap out the r squared, and instead we're going to write this x squared plus the y squared. To get rid of the fraction on the right side of the equation, we can multiply both sides by x squared plus y squared so that it'll cross cancel. And on the left side, you're going to notice that we're just multiplying two of the same things together. So let's go up here where we have a little bit more space and continue. So that will be on the left side, we'll have this x squared plus the y squared. That'll be all squared because we have two of them on the left side now. And on the right side, the x squared plus y squareds will cross cancel, and we'll just be left with 2 times x times y. This will be a rectangular form of this equation. For example 10, let's try the equation r is equal to 2 times sine of 3 theta. So the tricky thing about this problem is this sine of 3 theta. Now we want to remember what our sum and difference formulas are for our trig identities, and we know that if we can separate the sine of 3 theta into maybe 2 theta plus 1 theta, that's something that we can work with a little bit more. So let's go ahead and rewrite that. So we can write the radius is equal to 2 times sine of, and instead of writing 3 theta, let's separate that into two different angles and write that's going to be 2 theta plus just 1 theta. So we've separated it into a sum, and we can really call this 2 theta our alpha, and we can call this single theta our beta. So if we take a look at our formula down here, we can just then use our sum or difference. In this case, it's going to be the sum. Using our sum formula, we can write r is equal to 2 times sine of alpha. Well, alpha we know we said was going to be 2 theta. That's going to be multiplied by cosine of beta, which we said was just theta. And that's going to be adding on cosine of alpha, which we said was 2 theta. And that's going to be multiplied by sine of beta, which we know is just a normal theta. And don't forget that this 2 in front is going to be multiplied by the entire thing. So let's just keep all of this in parentheses. Now to continue on, we have to notice that this sine of 2 theta is one of our double angle formulas. And we're also going to want to notice that this cosine of 2 theta is another one of these double angle formulas. So we're going to have to make these substitutions in and do so right now. On the left side, we're going to have this lonely little r is equal to 2 times the quantity of, let's make a substitution for sine of 2 theta. That's going to be 2 times sine of theta times cosine of theta. That's just going to be our double angle formula there. And that's going to be still multiplied by cosine of theta that was originally there. And that is going to be added onto, let's see, what's cosine of 2 theta? Well, we can make a substitution using our double angle formula, and that's going to be cosine squared of theta minus the sine squared of theta. This whole thing is going to be multiplied by the sine of theta that was already there. And there you have the substitutions using our double angle formulas. Here was one of our double angle formula substitutions, and this was the other. Now let's just go ahead and simplify this bit and multiply cosine of theta by what we have inside there. That's all just going to be one term, so we'll have r is equal to 2 times the quantity of 2 times sine of theta, and cosine of theta times cosine of theta, that can just simplify, and we can write cosine squared of theta. Okay, so that's that first piece. And looking at the second term inside here, let's see what we can do. So looking at this whole thing, this sine of theta, we can just distribute to both of these terms, and we can go ahead and just write inside here sine of theta times sine of theta times the cosine squared of theta. I think that's right, yep. And then minus, well, we have sine of theta times sine squared of theta, so that's going to be sine cubed of theta. Looking inside these brackets, we have 2 of these sine theta times cosine squared of thetas, but then we have 1 more of them right over here. There's a coefficient of 1. So they're like terms, we can combine those. And underneath this, I'm going to write r is equal to 2 times the quantity of this, now 3 of these sine of theta times cosine squared of theta. And we have a minus sine cubed of theta. Combining like terms, we can write r is equal to 2 times the quantity of 3 of these sine of theta times cosine squared of theta, and we're going to have minus sine cubed of theta afterwards. Now, since we're running out of room here, I'm just going to go ahead and delete all of this, or just move it away. And let's move this and drag it up so we have a little bit more space. So at this point, let's just go ahead and take this 2 that's on the outside and distribute it into both pieces that are inside here. And if we do that, we can write r is equal to 6 times sine of theta times cosine squared of theta, and then minus 2 times sine cubed of theta. Now that we don't have any double angles or sum of angles or anything like that, we can just go ahead and now do all of our substitutions using our trig functions. So for this sine of theta, that's right over here. We know that's going to be y over x. So I'm going to start with that one. We'll do one piece at a time. So we'll have r is equal to 6 times the quantity. What's that going to be? That substitution is y over r. So we'll go ahead and write y over r. Okay, that's what sine of theta is equal to. And now for cosine squared of theta, that's this piece right over here. Well, we know what cosine of theta is equal to. That's x over r. So making that substitution, we're just going to square that. And we can then go ahead and just write that's going to be x squared over the r squared, right? So x over r squared is just x squared over r squared minus 2 times. And let's take a look and see what this sine cubed of theta is. Well, we know what sine of theta is. That's going to be right over here again. That's y over r, but we're going to have to cube it. So go ahead and write, let's see, that's going to be y cubed on top. There's a lot of pieces to this equation, over r cubed on bottom. Multiplying this mess together on the left side, we're going to have r is equal to, I think this is just going to be 6x squared times y. I think that's the entire numerator. And that's going to be all over r times r squared, and that's going to be r cubed. Okay? And cleaning up this right term a little bit, 2 times the y cubed on top is going to be 2y cubed in the numerator, and that's going to be over r cubed in the denominator. To get rid of the fractions, we can now just multiply both sides of the equation, multiply by r to the third power, r cubed. And if we do so, then on the left side, we'll be left with r to the fourth power. And that's going to be equal to, well, all the r cubes in the denominator are going to cross cancel. So we'll just have 6x squared times y. And then we'll do minus 2 times y cubed. Now we're going to run out of room again, so I'm just going to go ahead and get rid of this for now. And let's move this up so we have some more space to work with. All right, so the final substitution we're going to have to make is taking a look at this r to the fourth power. We know what r squared is equal to. That's equal to this right over here. So maybe what we can do is we can write this as r squared, but that whole thing is squared. All right, so if we go ahead and take a look at that way, we know r squared, what that's equal to. So going ahead and making that substitution, we can then just go ahead and write this will be on the left side x squared plus the y squared. And that whole thing is going to be squared. And that's going to be equal to 6 times the x squared. This is the right side. I'm not really doing anything. We're just copying it down. And this is minus 2 times y to the third power. After all that, this is our equation in rectangular form. For example 11, let's try the example r is equal to 2 over 1 plus sine of theta. To get started, let's multiply the right side of the equation by 1 minus sine of theta over 1 minus sine of theta. By doing so, we can rewrite the denominator as a difference of squares and then use a Pythagorean identity. So on the left side, we still have r is equal to. In the numerator, we're just going to take that 2 and distribute it to this 1, and then distribute that over to this minus sine of theta. And so we would have 2 minus 2 times sine of theta in the numerator, And on the denominator, we would then go ahead and FOIL, or we can just say this will be 1 minus sine squared of theta. Remembering our Pythagorean identity of sine squared of theta plus cosine squared of theta is equal to 1, this 1 minus sine squared of theta is the same thing as cosine squared of theta. Substituting that in, we can write r is equal to 2 minus 2 times sine of theta all over cosine squared of theta. At this point, let's see if we can get this r to say r squared, and we can do so by multiplying both sides by r. So on the left side, r times r, that's going to say r squared. And on the right side, if we distribute that r to the numerator, it would say 2r minus 2 times r times sine of theta. And that whole thing is going to be on top of this cosine squared of theta. If you're not sure where we're going with this just yet, just hang in there with me. I promise it's going to make a lot of sense in just a little bit. Next, we're going to go ahead and multiply both sides of the equation by cosine squared of theta so that it cross cancels on the right side and we move it over to the left. Let's see what that's going to get us. So by multiplying both sides by cosine squared of theta, on the left side we're going to have r squared times cosine squared of theta. That's going to be the left side of the equation. And the cosine squared of theta is going to cross cancel on the right side of the equation, so we will just have 2r minus the 2 times r times sine of theta. On the left side, let's rewrite this so we have this r times cosine of theta, and let's say that the whole thing is squared instead. That way we like that r times cosine of theta. That's something that is familiar to us. On the right side, for now, I'm just going to leave this alone and say this is still 2 times the radius minus 2 times r, or the radius times sine of theta. We'll just kind of leave that alone for now. Okay. This is where we're going to start getting rid of some of the r's and thetas and turn it into more of a rectangular looking form. So let's see, we have this r cosine of theta, and we know what that's equal to, right? That's just equal to x. So on the left side, we're going to swap out an x and say this is going to be x squared. Okay, that's much better. And on the right side, let's see what we can do as well. Well, what is this r over here to the right? Well, we still don't really know what that is, but if we do know that r squared is equal to x squared plus y squared, then r would equal the square root of x squared plus y squared. So maybe on the right side, this is what we'll do. We'll say 2 times the square root, and let's put that x squared inside and then add on the y squared as well. So that would be the same thing as our r value. And we can take away, there's another substitution. So we have 2 times this r sine of theta. So what's r sine of theta? Again, that's just our y value. So we can say this is minus 2 times y. Now this is looking a lot better since we just have x's and y and we no longer have any r's or thetas. Now we just have to clean it up a little bit. First, to get the radical alone, let's just go ahead and divide the entire equation by 2. And if we were to do so, then on the left side, what are we going to have? We're going to have x squared. That's going to be over 2. That's going to be equal to, well, the 2's are going to cancel out for this next term. So we're just going to have the square root of this x squared plus the y squared. Go ahead and write it just like this. And then the 2 and the 2y is going to cross cancel as well. So it's going to be just minus a y instead. So at this point, we're running out of room. So I'm just going to get rid of all of this. And we're done with it, so let's kind of just move it out of the way. Let's move this over up here and continue working. So at this point, let's add y to both sides. And if we add y to both sides, then we're going to have, well, we'll still have this x squared over 2, but then we can write plus y. That goes along with it to the left. And this is going to be equal to the square root of the x squared plus the y squared. Squaring that x squared over 2, that's going to then be x to the 4th power over 4. And then we're going to have those middle terms. So what's that going to be? Well, I think we're going to have basically x squared y. That's going to be all over 2. Plus another x squared. This is a perfect square trinomial. So it's plus another x squared y over 2. And it's going to be plus a y squared at the end. And on the right side, the radical is going to cancel out, so we're really just going to be left with x to the second power plus y to the second power. Now let's just combine these two middle terms, since these are like terms, and the two halves are going to make a whole when we combine them. So on the left side, we're going to have x raised to the fourth power over 4 plus a whole x to the second power times y. And we're going to add on a plus a y squared. And what's that going to equal? That's just going to equal on the right side the same old thing we had over there, which is going to be x squared plus that y squared. Once again, we're running out of space just a little bit, so I just want to make sure this is nice and clear. So let's get rid of all that and move this up so we have a little bit more space. Subtracting y to the second power from both sides, we can then rewrite this a little bit more simplified and write x to the fourth power over 4 plus x to the second power times y, and that's going to be equal to just x squared on the right side. Slowly, it's getting a little bit more simpler as we go. Just clean that up a little bit. Now, to get rid of the fraction, let's just go ahead and multiply both sides of the equation by 4. It'll cross cancel on the very left side, so we'll just have x to the fourth power. And in the second term on the left side, we'll then have this 4 times x to the second power times y. And on the right side of the equation, we'll just have 4x squared. Okay, now we have no fractions, which is a little bit nicer. Notice how all the terms have an x squared, so let's go ahead and divide both sides, everything, by x squared, because it's our greatest common factor. And we can simplify just a little bit more. So we'll have x to the second power plus, let's see, 4, I guess, y, because the x squareds are going to cancel out. And that's going to be equal to, I guess, just a 4 on the right side, since the x squareds cancel out again. Subtracting 4 from both sides, we can set this whole equation equal to 0, and we can write our final rectangular form of x squared plus this 4y minus 4, and that's equal to 0. Finally, that's our rectangular form of the polar equation we were given to begin with. For example 12, let's try the equation r is equal to 6 over 2 minus 3 times sine of theta. To rewrite this equation in rectangular form, let's start by multiplying both sides by 2 minus 3 times sine of theta. That way we don't have a fraction anymore, so on the left side we're going to have r multiplied by that whole thing, so it's going to be r times this 2 minus 3 times sine of theta, and on the right side we're just going to have a 6. By distributing this r to both terms right over here, we can then just say we have 2r minus 3 times r times sine of theta. I like that. We have the r sine of theta. That should look familiar to us, and that's equal to 6. Oops, there we go. Again, this r sine of theta should look kind of familiar to us. R sine of theta is just equal to y. So making that substitution, we're going to have 2r minus 3y, that's our substitution, and say that's equal to 6. So we got rid of the theta, but we still have to deal with this radius, this r. We have to get rid of that. So to do so, maybe let's try to isolate it and then maybe square it, so we have an r squared, and we know how to work with that. So if we add 3y to both sides, we'll have 2r is equal to 3y plus 6. Okay? To get this r into an r squared, which is going to be a little bit more useful to us, let's go ahead and square both sides of this equation. Going ahead and squaring this, let's rewrite that up here. So if we square 2r, that's going to be 4 times r squared. Don't forget to square the coefficient as well as the variable. And the right side, we're going to have a quadratic, so we're going to have to factor that. That's going to be what? We'll have 9y squared. The 3y squared is going to be 9y squared. And if we have a 3y times 6, that's going to be 18y, and double that because there's going to be 2 of them. That's going to be plus 36y. I think that makes sense, yeah. And then 6 squared is going to be plus 36. That's positive. So we worked so hard to get this r squared on the left side, so we finally have that here, and we can make the substitution. We know that's equal to this x squared plus y squared, so we can go ahead and rewrite this and say this is 4 times the quantity of this x squared plus the y squared. So just going ahead and substituting that in on the left side of the equation. And on the right side, nothing's really going to change right now. We just have this 9y to the second power plus this 36y. and we still have a constant of plus 36. Going ahead and distributing this 4 to both of these terms on the left side, we should then be able to write that we have 4 times x squared plus 4 times the y squared. That should be the left side after we distribute. And on the right side, I'm just going to rewrite it one more time as saying 9y squared plus the 36y and plus the 36. So we have these like terms of 4y squared and 9y squared. So if we subtract 9y squared from both sides, we can then go ahead and write 4x squared on the left side, but 4 minus 9 is going to be negative 5, so minus 5y squared. And then we can take away 36y from both sides, just move that to the left side, so we'll write minus 36y. And while we're at it, let's move this plus 36 to the left side as well, so we can just write minus 36 and set that equal to 0, so everything is on the left side. And that would be our rectangular form of this polar equation. And for one final example, let's try example 13, where we have r is equal to 6 over 2 times cosine of theta minus 3 times sine of theta. What we can do right away here is look at this cosine of theta and this sine of theta. And so cosine of theta, which is right down here, we know is going to be x over r, and sine of theta, which we have right over here to the left, that's equal to y over r. So rewriting this using our ratios, we can say we have r is equal to 6 over, and we're going to have 2 times, well, what's cosine of theta again? Well, we said it's going to be x over r, so I'll go ahead and rewrite this as x to r, just like that. And we're going to have this minus 3 times sine of theta. Well, sine of theta we said was y over r, so I'll go ahead and write y over r. Going ahead and multiplying this 2 times x over r and the 3 times y over r, we can rewrite this equation as r is equal to 6 over, let's see, that's going to be 2x over r, and then it's going to be minus the 3y over r. Notice how we have common denominators on the denominator. I know it's a little confusing, but that's actually kind of nice. So we can continue this up here. And on the left side, we can say that r is equal to 6 over. And on the numerator of the denominator, we can write 2x minus the 3y. And that's going to be all over, and let's just write r one time. So the right side's a little bit confusing since we have a fraction in a fraction, so let's just rewrite that. So 6 is going to be 6 over 1, and we're really going to be dividing that by this 2x minus 3y over r. So if we're going to divide that, we really could multiply by the reciprocal, and so we'll multiply that by r over, let's see, 2x minus 3y. Multiplying the right side out, we can get r is equal to 6r in the numerator, and in the denominator, we're just going to have 2x minus 3y. All right, so it's looking a little cleaner, but we need a little more space just to finish up this problem. So let's just get rid of all this and clear up some space and move this over here. And what can we do? Well, maybe we'll go ahead and just multiply both sides by this 2x minus 3y just to get rid of the fraction. So multiply both sides by 2x minus 3y. Multiplying both sides by that 2x minus 3y, on the left side we'll have r times the quantity of that 2x minus the 3y. That'll be the left side, and on the right side, that 2x minus 3y will cross cancel, and we'll just have 6r left on the right side. On both sides of the equation, if we go ahead and divide by r, then we don't have to deal with that anymore because it'll cross cancel on both sides. So on the left side, we'll have this 2x minus the 3y. And on the right side, we're just going to be left with a 6 since the r's are going to cross cancel on the right side as well. Adding 3y to both sides and taking away 6 from both sides, we can rewrite this equation as saying 3y is equal to 2x minus 6. And dividing both sides by 3, we can go ahead and rewrite this final equation as y is equal to, what is that, 2/3 x minus 2. And this right here would be the rectangular form for the given polar equation we had from the beginning. And that just about wraps up this video on 13 different practice problems on converting polar equations into rectangular form. If you found this video helpful, it would really mean a lot to me and the channel if you could give the video a thumbs up, maybe leave a comment, and even consider subscribing. And as always, keep up the great work, and I'll see you in the next one.